Today we're going to look at solving right triangles. Not only are we going to look at solving for different side lengths, but also we're going to get inside the triangle and look at how to find the measures of certain angles. So when solving right triangles, we've got two things. We've been discussing for a while how to find side lengths or any unknown missing side of a right triangle. We can always resort to the Pythagorean theorem, which is a squared plus b squared equals c squared. Now we've introduced this concept. If you're given a side length and an angle, that's what we've used so far. We've used trigonometry, which is our three functions of sine, cosine, and tangent. Now, looking at all three, I wanted to show you an acronym to maybe help you remember the trig formulas and remember their order. So I want to introduce you to a little man named SOHCAHTOA. That's right, his name is SOHCAHTOA. And he helps us remember our trig formulas. Let me show you how. The first letter, which is S, represents the function of, or the trig function of sine. And we know that sine is the opposite over the hypotenuse. Our second trig function we have is cosine, represented by the letter C. And we know the trig formula for cosine is adjacent over hypotenuse. And the last trig function we have is T for tangent, and that is opposite over adjacent. So if you remember SOHCAHTOA, he will help you keep order on your trig functions and their actual formulas. Again, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now talk with your math teacher because they may know another acronym to help you with the trig functions. So let's get going today. If you are given side lengths and you are asked to find an angle of the triangle, you will use trig inverse. This is what today is all about, getting inside those triangles and looking for angles. So we're going to use trig inverse. What does that look like? It looks like the function of sine, cosine, or tangent all raised to an exponent of -1, if you see that right there. Now, if you look at your calculator right now, there is no button that you would press that looks exactly like this. It is written up above your trig buttons. So if you look at your sine button, up above it, normally written in yellow, it's in a different color, you will see sine raised to the -1. Up above cosine, you'll see this. Up above tangent, you will see this as well. So how do we initiate this function, or how do we get this calculator to read trig inverse? This is what you're going to do. Depending on what calculator you have, to initiate this function using your calculator, you will press the key that says either shift or the button that says second. You're going to press that one first, and then you will press the appropriate trig button that's at hand for whatever problem that you're working with right now. Let me show you. I brought up two calculators. One is a Casio, which is right here, and this is a TI calculator over here. So first example, we have the example of tangent of angle T is 3.5. Now notice, we don't know this degree measurement, but that's what today is all about. Let's figure out what that degree actually is. So this is what we do. First and foremost, you are going to press your shift or your second. I'm going to work with the Casio calculator on this one. So first and foremost, here's that shift button in the top left corner of your calculator. So press that one first, and then you go and press the tangent button. Why tangent? That's the trig function that's at hand. So this is what we're telling the calculator to read. The trig inverse, or the tangent inverse, of 3.5. After you put the 3.5 in, hit enter. And after you hit enter, your calculator should come up with 74, we're going to round to the nearest tenth, 0.1 degrees. So remember, we're all about finding what the degree is. All right, let's look at this. Sine of angle D is 0.37. Now I'm going to use the TI right here. Again, to figure out this angle, we have got to use the sine inverse function. First and foremost, on the TIs, you would press this button in yellow/orange. It's your second button. Press the second button and then press your sign. Why the sign button? Because that is the trig function at hand. So you will notice if you're working with a TI, this will definitely pop up in your screen and it will open a set of parentheses for you. What you're going to put in those parentheses is this decimal right here, which is 0.37. You can close the parentheses if you want to, but you do not have to. Let's go ahead and close them. And then hit enter or equals. And your calculator will tell you that the degree of this is 21.7 degrees. Now the same will work for the cosine function as well. Again, we're using trig inverse so that we can figure out the degrees for these triangles. Let's get going into some problems. But first, remember this, that trig inverse is helpful when finding degrees, not side lengths. Helpful when finding degrees, not side lengths. Let's get going. First example, find the side length of D, which is located here, and find the measure of angle D, and find the measure of angle E. Round all the answers to the nearest tenth. Since this is the new portion today, finding these angle measurements, because the only angle measurement we have is the 90 degrees, let's get going and find measure of angle D first. So if we are looking from the measure, if we're looking from angle D, which is over here, this is what I want you to do. I want you to label with our vocabulary. Our vocabulary is hypotenuse, opposite, and adjacent. It's our trig vocabulary. We have trig functions and trig vocabulary. So I want you to label in respect to angle D. This is where we're looking from. How would you label the 12? 12 would be the adjacent. Great. Now, still, we're looking from angle D. From measure of angle D, how would you label 14? Well, considering that 14 is across from the 90-degree angle, this is our hypotenuse. So question to you is, which trig function uses both of these vocabulary terms, adjacent and hypotenuse? You're right, it is cosine. So we're looking at the cosine of angle D. Now let's finish off this sentence here. Cosine of angle D is, if we look back at SOHCAHTOA that you have in your notes, cosine is adjacent over hypotenuse. Now we already know that the adjacent, let's erase that word, and let's put in 12. And we also know that the hypotenuse is 14. So let's put that in. So now we've got cosine of D equals 12 over 14. Let's reduce this fraction here. Let's turn it into a decimal. So cosine of angle D is, and if you do 12 divided by 14, let's go out 4 places, 0.8571. And remember, the whole point is to find the measurement of this angle. So how do we find angles, or how do we find the degrees? We've got to use trig inverse. This trig function is at hand, cosine. So here we go, calculators. Press shift or press the second button, and then press your cosine button. Put in the decimal of 0.8571, hit enter, and we will have that the measure of angle D is 31.0 degrees. Good. Okay, let's clear some space here. All right, now let's find the measure of angle E. Now we're looking from up here at the top of the triangle. So in respect to angle E, how would you label the 12 from our vocabulary terms over here? You're right. It is opposite. And we know that 14 is the hypotenuse. So now let's figure this out. What trig function uses the vocabulary of opposite and hypotenuse? You're right. It is sine. Sine of angle E. And if you look back at SOHCAHTOA up there, or if you've already memorized the sine formula, it is the opposite over the hypotenuse. So we've got 12 over 14. We already know what 12 over 14 is. So we have sine E equals 0.8571. Now we're trying to find degrees here. We're trying to find an angle measure. So we have to use trig inverse. So press the shift or second button so that we are initiating the trig inverse function. And put in your decimal of 0.8571. And we find out that the measure of angle E should be 59.0. Now let's go ahead and finish out this right triangle. The only thing that we haven't found, we found E already, and we found the measure of angle D. We know the measure of angle F. We have this side length, but not this one. So let's use our old school Pythagorean theorem. A squared plus B squared equals C squared. And let's figure out this leg length of D. Put in one leg length, which is 12 squared, and then we have the unknown, and then we have 14 squared. 12 squared is 144, and 14 squared is 196. To get D by itself, I'm going to subtract 144 to the other side, and I've got D squared equals 52. Not good enough yet, though. I got to get D by itself. So let's square root both sides, and let's round this to the nearest tenth as well. So I have D equals 7.2. As of now, there is no unknown information for this triangle at hand. We have solved this right triangle. Let's do one more and call it a day. We've dealt with the sine function and the cosine function and Pythagorean theorem. Let's see what's at hand now. So find the measure of angle S and round answers to the nearest tenth again. Where's angle S? Down here. Okay, so this is where we're looking from. And let's see, obviously this is right triangle, sorry about that. Obviously we've got two pieces of information. We have a side length of 2, and we have a side length of 6. In respect to angle S, how would you label the 2? Which trig vocabulary word would you use? I hope you said opposite. So I'll ask again. In respect to angle S here, how would you label the side length of 6? And I hope you said adjacent. Next question. What trig function uses these two vocabulary words? It is tangent. So we're looking at the tangent trig function for this one. So tangent S is, that formula goes, opposite over adjacent. What is our opposite length? It's 2. What is our adjacent length? 6. All right, let's go with it. Tangent of S is 0.3333. 4 decimal places to keep it accurate. Now remember, we're trying to find the measure of this angle, so we have to initiate our tangent inverse button or tangent inverse function. So hit your shift and then tangent, or hit your second button and then tangent. Put this decimal in of 0.333. Whoops. And your calculator will tell you that the measure of angle S is 18.4. We have done it all. See you guys in class.